Hello, ladies and gentlemen, and today we're going to look at graphing absolute value equations. Basically, we're finally expanding upon lines. Yay! So, what you're going to want to keep in your mind, the value begins with a V, because all of our graphs are going to look like V's today. What you're going to want to have on you, you're going to want to have your notes, pen or a pencil, and then you're also going to want a calculator to do some simple addition and subtraction today. Your learning objectives. I can graph an absolute value function using a table. So today we're going to basically make a graph using a table, which is nothing new. We've done it before. So here's my very first graph. Y equals absolute value of x. Remember the two bars there, that's absolute value. Now, this is what's known as a parent function because there has not been any changes done to it. It's just absolute value of x. So this is what's known as your parent function of this particular graph. What you're going to always want to do is whatever's inside the absolute value, you're going to want to set that equal to 0. That's going to let you find your vertex or this middle point right here. So x equals 0, it's already solved for. So I'm just going to have a 0 right there. They're going to fill some numbers in, that's some negative values and some positive values. That way you get both sides of your V. Otherwise, you're not going to get one side and you're just going to be like, why is it a line, Miss Marsh? And then you're going to be confused. So make sure we always set whatever's inside the absolute value bars equal to 0 and then put some numbers around it. Now, let's think here. I need the absolute value of negative 2. Absolute value makes anything positive. So if I have negative 2, my answer is going to be a positive 2. Absolute value of negative 1 is 1. Absolute value of 0 is just 0, and 1 and 2, right? Now, notice how this and this and this and that, whoop, that's a bad circle. Those two and those two are the same exact. That should always happen in an absolute value equation. You should see them always meet together like that. So let's graph. Negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. Look at that V for value. Perfect. Now, your vertex is this point right here. Basically the tip of the V, if you want to consider that. So my vertex is the point 0, 0. Which intervals are we increasing? Well, it looks like my V is going up in this function, this part of it, right? So we're starting at 0, but we're not including, remember, because we're just going to start there. And it looks like we're shooting off forever to the right, or shooting off forever to infinity. This is the negative infinity side, right? Decreasing, it looks like we start at the negative infinity side, and we stop at 0. Now, what about our domain? Well, I'm going forever in both directions. So, negative infinity to infinity, right? What about my range? Well, it looks like if I look from the bottom to the top, it looks like I'm starting at 0, so I can include 0. Oops. And then, running out of room. And then I can go forever infinity. And then, do I have a maximum or a minimum? Well, I have a valley, so I got a min. And my minimum is 0, 0. Basically, your vertex. Let's try a second example here. So I got to find what makes this equal to 0. So let's do that off to the side here. 2x plus 1 equals 0. So subtract 1, divide by 2. So I get x equals negative 1/2. That's what makes this equal to 0. So that's going to go right here. Now, I need to put some numbers around that. Let's go negative 1, negative 2, 0, and 1. Now, I could have picked negative 1. I could have picked negative 1.5 right here. But why do hard math? Do easy math. Don't be a superhero. Okay? So let's plug in our x. I have negative 2, so I have 2 times negative 2 plus 1 in absolute values, subtract 4. Well, inside here, 2 times negative 2 is negative 4. I add 1, that's negative 3 in the absolute value, right? But absolute value means positive, so 3 minus 4 is negative 1. Let's do it again. 2 times negative 1 plus 1 minus 4. 2 times negative 1 is negative 2. Plus 1 is negative 1, so I'm going to have negative 1 in the absolute values. 1 minus 4, well, that's negative 3. Let's plug it in a half. Well, we know already that the half makes the inside 0. So 0 minus 4 is negative 4. Easiest point to fill in. Let's plug in 0. So I get 2 times 0 plus 1 minus 4. So 2 times 0 is 0, so I'm going to get a positive 1 in the absolute value. Oop, that's minus 4. 1 minus 4 is negative 3. Let's plug in 1 now. Oops, that's supposed to be absolute value. 2 times 1 is 2, plus 1 is 3. 3 minus 4, negative 1. Notice I have that rainbow matching, kind of a mirror effect around our vertex. So let's graph. Got negative 1/2, negative 4, right there. 0, negative 3, negative 1, negative 3, 1, negative 1, and negative 2, negative 1. Let's see if I can graph that. Ooh, that's pretty good actually. Oh, that's actually pretty dang good. Notice it's kind of like a V that's kind of been squished a little bit on both sides. So my vertex is negative 1/2, negative 4, middle of my table. My domain, fill in my values here. Well, it looks like I'm going from negative infinity to positive infinity. What about my range? Starting at negative 4, and then I'm going forever going upwards. What about increasing? Looks like I'm increasing from there to there, so from negative 1/2, because remember, you're always going to be looking at your x, to positive infinity. And then I'm decreasing from negative infinity to negative 1/2. I have a minimum, because I have a valley, and my valley is at negative 1/2, negative 4. Let's check our third example here. So I gotta find what makes this equal to 0. So x minus 2 equals 0. So I'd add 2. And I'll get x equals 2. So that's gonna go right, whoops. That's gonna go right here. So 2, fill in some values around. At 0, I get 0 minus 2 plus 3. It's negative 2, absolute value. I will get positive, negative 2 plus 3 is a positive 1. Now it looks like we gotta continue here, so let's put in 1. So I'll get negative 1 minus 2 plus 3. Well, negative 1 or 1 minus 2 is negative 1. Absolute value of that, 1. Tack the negative back on, so that's negative 1. Plus 3, 2. If that's not confusing, I don't know what is. So let's plug in the 2 there. So I got negative 2 minus 2 plus 3. Well, 2 minus 2 is 0. Tuck the negative on. That's still 0. Plus 3, 3. Let's plug in again. So I got 3 minus 2 plus 3. Well, 3 minus 2 is 1. Absolute value, 1. Negative 1, because of the negative. Plus 3, 2. Negative 4 minus 2 plus 3. So I got 2. Absolute value is 2. Negative 2 plus 3, 1. So let's graph here. I got the point 0, 1. Whoops. And I got 1, 2. And I got 2, 3. 3, 2. And 4, 1. Oops, started a little off. There we go. Notice though I got an upside down V. So my vertex is at 2, 3. My domain. So if I write negative infinity to infinity, same thing. Negative infinity to infinity. going to give you a hint. The domain is always going to be negative infinity to infinity, alright? Your range then. It looks like I go forever in the bottom half, but I stop at 3, so we're going to actually have brackets around 3. What about increasing? Well, it looks like I'm increasing because I'm going from this way, right? So negative infinity to the x value of my vertex, 2. Then I'm decreasing from 2 to infinity. This time it looks like I have a max, right? Because I have a hill. So I'm going to be at the point 2, 3. Just a little summary. So your summary, absolute value graphs are in a V shape. You're going to find the vertex by finding the x value. That makes the absolute value expression become 0. You're going to want to complete the table, plot the points you get, and then ask yourself, is it a V shape? Because it should always be for a giant V for value. And that's the end of this video. See you later, Sabers.